Hello guys, welcome in this new video. So in this video we will be just completing our topic of data structure and algorithm with these last 4 or 5 algorithms, and then we will move to other topics, and beginning with the first algorithm of today's video is the Dijkstra's algorithm. So it is actually uh, used to find the shortest path from the source to the source vertex to all the vertices in the given graph, and it is similar to the Prim's algorithm for the minimum spanning tree, like as I discussed in the previous video as well. So like Prim's MST, that is minimum spanning tree, we generate a SPT, that is the shortest path tree, with a given source as the root, and we maintain two sets. One set contains vertices included in the shortest path tree, and others includes vertices not yet included in the shortest path tree. So at every step of the algorithm we find a vertex that is in the other set and that is not yet included and has the minimum distance from the source. So you can check for the details here if you want. Just I'll show that. Let's say this graph is given. So if we start from the zeroth vertex, then we will check for the left one and then right one, and we will check how much weight it is getting. Then let's say the lower weight will then be traversed first, that is here first node is there. Then we will go to the next node, the nearest neighbor node, we will check there as well. Then we will check for the this seventh node as well, because it is kind of a BFS, that is the breadth first search kind of approach here. And similarly we will do on and on here, and at last we will get the Dijkstra's algorithm completed. Okay, and it will tell us the shortest path from the source vertex. Actually here it is kind of a minimum spanning tree which have been made here, but it will show us the minimum length between the source vertex and all the vertices that can be reached from here. So let's say if you want to reach from 0 to 2, then this is the only path that can be taken. So it will always lead us to a shortest path from the source vertex to the other vertexes. Now let's say we have a negative weights in this. Then what we will, for that we have another algorithm known as bellman-ford algorithm. So basically, as Dijkstra's algorithm is a greedy algorithm, so it doesn't work for graphs with negative weight cycles, and bellman-ford is the algorithm that solves this issue. Now what you can say about the time complexity of Dijkstra's algorithm is that it is of order of v plus e log v, where v is the vertices, number of vertices, and e is the number of edges. Now Bellman-Ford is also simpler than Dijkstra's and suits well for distributed systems, but the time complexity of Bellman-Ford is order of VE, which is more than Dijkstra. So you can check for this algorithm as well, but this is not that much important, because in the exam you just need to focus on solving the and taking out the shortest path, because all these algorithms will lead us to the shortest path. Okay, now coming to the floyd-warshall algorithm. So basically this algorithm will give us the shortest path between all the pair of vertices. Let's say the every combination of the nodes from one node to another in a graph, and it will give us all the shortest path in those combinations. So let's say you have this graph that I discussed as of now. So let's say you have 0 to 1, and then this is only the source vertex here in Dijkstra's algorithm. But in the floyd-warshall, all the nodes will be the source vertex. So one method is that you can apply Dijkstra's algorithm for all the vertices, but it is not a good time complexity solution. So the Floyd-Warshall algorithm comes into play. Now it is also valid for the edge weighted directed graph, and you can see for its algorithm here as well. Basically it can also be used, it can be also solved using the dynamic programming question and approach, and uh, as this is also not supporting the negative weights, so for that we have Johnson's algorithm for this one. And as this is somewhat similar to Floyd-Warshall. So what it is there is it uses actually both Dijkstra and Bellman-Ford as the subroutines to find the shortest path from all pairs of vertices. Okay, and the basic idea behind this Johnson's algorithm is to re-weight all edges and make them all positive, then apply Dijkstra's algorithm for every vertex. Okay, now coming to the Dial's algorithm, that is the last of this the last part of this video. So basically, as Dijkstra's algorithm runs in order of e log v time when implemented using adjacency list representation. So we have this Dial's algorithm which will actually uh, can be used for small weights, and it can be solved in order of e plus wv, where w is the maximum weight on edge of the graph. So just this was some brief review about what these are and some description about them. But from the point of knowledge view, you should know them. But as from the point of examination, you should basically just know how to determine the shortest path from every vertex. So it's all up to you which algorithm you use. And thank you for listening, and I hope you understood whatever I told. And till the next video, keep learning and keep watching.
Untitled.